we're gonna add a parametric sweep. We're gonna do a parametric sweep, and that will be for the charge rate during simulation. So under steady, adding a parametric sweep. So you right click on steady to add the parametric sweep. And under the steady settings, what we do is for the parametric name, we're gonna select the charge rate during simulation, and we're going to specify the parameter value list, which will be I mean 4, like this. You click step 2, move to step 2, time dependent. And under the steady section, in the times, we're going to change this range to be 0. In time, we have to spend time. We go ahead to compute. So this might take a little while to compute, depending on how fast your machine is. So finally done computing, and we can start plotting our results. So we go to, we have electrolyte current density, we have potential with respect to ground, okay. So to add our 3D plot group, We had 3D plot group. Okay, so in the label field, what we'll type here is the potential in negative current. And data section is 31. Parametric solutions. The times, let's choose from look at the color legend. Maximum, I want to show the maximum and minimum. We want to show the maximum. We want to show the maximum and the minimum values. And the number of formats, which we're going to expand. We want to select the manual color legend. Right click on this to add a volume. Okay. So in the volume, locate the expression in here. And under here will be the fist. Once you select the selection here, selection, I'm going to choose the negative current collector and tab. It should be potential negative current. collector and tab. We plot. We're gonna take the position to 4. Yeah. So after doing this, we want to duplicate this plot. To get the potential at the positive current collector and tab. So here we tap potential in the positive current tab. A positive current potential and tab has to change to the side. So we're able to see the potential at the negative and that's at the positive. So having done that, what we do next is we want to plot the relative current density across this separator using a slice plot. So we add a 3D plot group. We want to type relative current density across the separator. Now we from the parametric solutions. We come and we choose a slice in here. As you can see, slices. Locate the expression at the slice. I'm going to change it to one C. Rates And we have the H cell. Okay, so we have it this way. Okay, so over here it is capital L-I, that's caps I, and we have a small L, which will give you a unit of 1. So with that, you don't have any issue over here. So in here is a capital I and small l before capital M and small ag. So when you input it this way, you should not have any issue. Okay, so now we locate the plane. Okay, over here. We've done that for the z coordinates. And what we'll do next is you want to go to the relative current density across the separator times 630. And if you plot, this is how it should look like. We'll add another plot group, add a 3D plot group, and the final 3D plot group that we're adding. And we'll call this the utilization. As a relative capacity. We put and we'll do next is under the data section, as usual, will be there. This time, as you always do, we look at the steady parametric solutions during. Here, we're going to choose one. Color legend, we want to show maximum and minimum values. Want to plot the surface and the expression section. It's a bit tricky sometimes with the I and the L's. double checking to make sure. So what we do is to identify this for the second one, which we are referring to, we add number 2 here. We have to add 2 here to indicate that we are calculating for the positive side. So when we add the 2, then it changes to 1. Then what we'll do next, we're going to choose selection. And in selection, we're going to select boundary fixing only. So we select boundary system only. This is what we have in here. So this is our plot, as you can see. So what I'll just remind you to be cautious of is this side where we have to input our expression. So you need to get it like well. So if you remember that over here in our definitions, the positive side is the second one. So that's why we have the general projects 2 in here. So at the end, it should resolve to 1. Remember, here is a small l, here is a capital I. So you make sure you input this carefully to get 1 before you're able to get this plot as I have done in here. So basically, this brings us to the end of our work, and I'll see you in the next video. If you have any questions, kindly let me know under the comment section.